I'm your host, Sean MacKenzie. Thanks for joining me once again on my channel on data analytics and data engineering. In this episode, we're going to return to our Microsoft Access playlist, and we're going to talk about how to emulate a lag and lead function, which are two window functions that you can find in SQL Server and some other bigger databases that sort of allow you to calculate things between records as opposed to in the same record or using a join. So sometimes it's very useful to look at the record just before the previous record and take some some measure from that record or some variable, and then use that in the current record to calculate something. And a good example for that would be statuses. So the status of item A went into this status on one day, and then the next day it went into a different status, and we want to know how long was it in the second status. And so and that's how we can use the lag and the lead function. Now, one of the big problems with Microsoft Access is that it doesn't support natively lead and lag window functions, and so we kind of have to make up our own. And there's a couple of methods for doing that, and I'm going to show you those today. So without further ado, let's get to our lead and lag functions. Okay, so to get started, we're going to look at our Access data database that we used in our previous episodes. And I've created a small data table with some sequential dates for events in it that has 100 rows in it, so we can use that to try our lag function. As you can see, it's got 100 rows, and the dates are in sequential order. And then I did a medium-sized data table with 100,000 records, and same kind of idea. I ran dates far into the future. Since there was 100,000 entries and they had to be sequential, I've gone into the year 3259, which is far beyond any of us, but that is the medium table. And then I did a big table where I did 500,000 records. I kind of ran out of dates after at about 8456, and once I hit 99.99, it was in the 600,000 range, so I thought I'd just trim it to an even 500,000 sequential dates just for comparison's sake. So in order to demonstrate a lag function, a lag is usually where we create a field in a query on the same row as our event date, but it has the date from the previous row in it, so that we can say, how many days has it been since the last one, or if it's an integer, what's the difference between the current integer and the previous integer, and things like that, if you're doing some kind of sequencing. And so what we want to do here is we'll say last event is equal to the DMax, which is the domain max function, and we'll say the event data small, because we're looking at the small table because there's only 100 entries. And then we'll say the event date is less than, so we're getting the maximum date where the date is less than the current date. And so we'll use the literal hashtag there for our date, and then we'll put in, we'll make a concatenated string here. We'll plop the current event date in there, and then we'll put the ending literal hashtag on. And so what that's going to do is it's going to find the date of the previous row, and it's going to put it on the current row, and that's exactly what we want to see. And if I jump up and use the view on the view tab there, you can see that with the exception of the first row, which has no previous date, it has gathered very quickly all of the dates. And so this is very handy, as we mentioned just before, if we want to make comparisons between rows. So we might want to show something like this. As you can see, once you have that field from the previous row, it's very easy to create a calculation of days, and we will use the date diff function, and I'll demonstrate that at the near the end of this video. Okay, so I'll save that as my date small query, and then from there we can see that that one went very quickly. There was only 100 rows in there, so we could use the DMax function quite nicely if we had a small amount of data to use our DMax in order to create our lag function. However, what if we decided to create a new query and we chose the medium size table, and that one has 100,000 rows in it, I think 10,000 might be a better number to try, but we'll also try 10,000 in a little bit here, but we're going to try 100,000 rows to see if our DMax function will perform as a lag function would, in order to give us the date from the previous row on the current row so that we can compare with the current date. So we'll use the DMax function once again, just as we did in our previous example for the small table. And I'll just save this as date medium here. And as you can see, when I run this one, it does render it right away. It shows it does show the dates in there. However, this is a neat little trick that Access does. When you open a table and you display it, it actually only shows I believe the first page, and so we can jump to the end. It will allow us to jump to the end. It takes a minute for it to get there, but it looks like we have everything calculated. However, this is only running the query for the end of the query. It's not actually calculating all of those dates in the 10,000 or 9,000 rows in between or whatever. So we're only getting sort of like the presentation of it, but we're not actually calculating all of them. So in order to do that, we do have to make a table which will force it to calculate all of those dates to actually get a true sense of how long this query takes to run. And we can do the same thing with our big table, data big, which has 500,000 rows in it. We'll do the same thing where we'll put in the DMax function just to see if we can get some results out of that, and this is going to make it for a very interesting comparison. So just like we did with our previous ones, we'll do a last event DMax, and then it'll be the event date, and in the big table where the event date is less than, and then we'll use our literal hashtags, and we'll put concatenate the current event date in there from the current row, and that's gonna put the event date from the previous record onto this row just as we want it to. So I'll go ahead and finish that up, and I'll go ahead and save this query here. I'll call it date big, and that's going to be a query that we can use to check our previous rows. Now in the same way of the previous query, we're able to open the beginning of the query here, and we can see that it has properly calculated at least what we can see, the first page of the calculations, and when we hit go to the end of the record set, it takes a while to get there, but it does eventually get there. However, it doesn't calculate everything between the starting page and the end page. It just skips through all the records in order to get to the end, and then it shows you the calculations for the very end. And so in order to really test our performance to see if this is viable as a lag function or a lead function, we need to do something that will cause it to calculate all of our data so that we can use it. And in order to do that, we're going to do what's called a make table query and that's going to force it to go through and calculate every value and then write it to a table. And so that's going to be a lot better of a measure to see if we can actually use this. So we're going to do the first one with the date small query, which is the query that has our lag dates on it. And we'll do a make table, and we're going to make a table, and we're going to call it data small, and then we'll call the query QMakeData small, and that's going to give us a make table query, which is going to allow us to paste all of that data into one table to see how long it actually takes for this method to work. And so I'll go ahead and I'll create the similar query for the medium size query with the lag dates in it, and that will allow us to see everything for the 100,000 records. And then I'll do the same for the big table. So I'll name this medium one QMakeData medium, and then I'll save that, and then I'll go ahead and I'll create our big table example, and that is going to be the same way. I'll just drag that on there, select everything, do a make table. I'll make a new table called make data big, and then I'll name the query QMake date data big. And so with those three queries, that'll give an honest sort of representation of how long it takes for these things to execute. And I might add that we get some interesting results, so make sure that you stick around and see what happens next. Okay, and in order to expedite this process and to show just how long these things take, I created a time query procedure here, and all it's going to do is it's going to open the make data query that I specify, and it's going to take the start time and the end time, and then it's going to show us just how long it took to run that. So very simple little procedure, and that's going to allow us to see how long it takes for our lag function using DMax, which is our first example. So in this case, we're going to use the make QMakeData small, and I'll hit enter on that, and it's like bang, done. It was done so fast it even said 0 seconds. And so that is a very quick query, and there's our table with the 100 rows in it, and I think that that's a pretty good example of how using DMax as a substitute for a lag function is actually quite efficient for small amounts of data. Now, if I choose QMakeData medium, that's going to do 100,000 rows, and we'll see if how long that might take by rerunning our query in the same way. So I just changed the name here to our medium query for the 100,000 rows, and then I'll hit enter and let that go in the immediate window just to see what happens. So we can see that we started, and to make a long story short, this sat there for the 5-minute time limit. This should, in my estimation, any query like this should run at least within 5 minutes, and it never ever did finish, and so we'll stop that one there. Okay, so if it doesn't do 100,000 rows, I adjusted it to try to do only 10,000 rows, which you're seeing now, and had the same result. Okay, and from there I'll try 1,000 rows, where I've changed the query to only take 1,000 out of that 100,000, and that query finished in about 36 seconds, which we'll see here. I've edited it just for expediency, and that one finished in 36 seconds. So we did get a finish on 1,000 rows. Okay, and just before moving on, I will note that I tried to run the 100,000 using an index and on the table, and that had no effect on the outcome. and also tried using a subquery, which I'll show here. 1 second. The subquery, you can see there's our expression for our DMax, and instead of using that, I put it into SQL mode here, and with SQL mode we're able to change our SQLs in ways that we can't do using the grid there. So instead of our DMax function there, I went ahead and changed that into a subquery. And just to speed that up here, I cut out some parts, and you can see I'm just building the subquery, selecting the max instead of using the DMax, and that this solution was also not successful in reducing the time. And just jumping ahead here to the query that I put together. This is the end here. I put a subquery with query.eventDate from data medium, where as query, where query event date is less than data medium event date, and that gave us the expected results that we wanted. For the initial opening, however, it also failed for running 100,000 records and calculating all of the rows. So if I go ahead and open my VBA console, I can run our query again for the medium size with the subquery, and it unfortunately failed, just to show you here. And this one took off, it started, but it just sort of sat there, and that one also was greater than 5 minutes and had to be killed. So in our fourth method that we're going to try today, and our successful method, is to actually use a procedure instead of using a straight query. And so what we're going to do is we're going to add a field to our data medium table, and that has 100,000 rows in it. We're just going to say that we want to have the last event date field in that table, and then in order to fill those values in there, we're going to write a short procedure to calculate the lag field values. This is a common problem in Microsoft Access when we do run into the sort of limits of the product. In the case of the query, it's causing many queries. If you use a subquery or a DMax or a DLOOKUP, what you're doing is you're causing that query to be rerun over and over again on each row of the result set. And so we don't want to do that. What we want to do is, because we don't have a native lag function in Microsoft Access, what we can do is we can write a procedure that'll just zip through the data set and populate that for us so that we can use it over and over again. And that's going to do it one time, or you can do it every time that you open it if you want to include that functionality in your application or in your data set. So to make this procedure, we'll go ahead and we'll just make our database and record set variables, and we'll create a last and next date, and then we can sort of start putting this together. I'll set the database equal to the current database, and then I'll set the record set equal to the name of the argument that we'll pass to our procedure for the name of the table that we want to do, because we might want to run the same thing on our big table, which we are going to do after we run the 100,000. We'll run 500,000, and we'll see how long each of those takes. And so we'll put a counter in there as a long integer, and we'll set that equal to 0 to start. And then all we want to do in our procedure is we're just going to open that table, and we're just going to loop through it really quick. And so we're just going to do a loop through, meaning we've opened it, and we'll move to the next record at the end of each iteration. And so what we can do is we'll set our dates equal to, we'll set the next date equal to the event date on the record, and we'll increment our counter each time that it goes through, just so that we have an idea where we are in the record set. And also we're going to pass a little bit of feedback to our immediate window as this runs through. And this will kind of show you the power of procedures in cases where you can't do set operations in an efficient way in Microsoft Access. And each time we'll go through our iterations here. We'll say if the counter is greater than 1, because we're not going to, there's no previous date for the first record. We'll say we're going to edit the record that we're on, and we'll say the record last event is equal to, see, what did I name that again? I called it last event. Okay, so just got to go back to my, so the last event is equal to the last date that we picked up as we went through, as we rolled through the record set. So in order to get that last date populated, we're going to set the just before we pass out of our iteration there, we're going to set the date, the last date equal to the next date, and those are going to repopulate each time that it goes through the loop. And so, and then we can check, and we can say if every time that our counter, every time we've hit 1,000 records, so that's what our mod function is going to be used for there. So every time we pass 1,000 records, we're going to print out where we are. So we'll debug.print our counter, and then we'll use do events just so that in case it locks up on doing so many records, each time it'll release control back to Windows for us in each 1,000 records that it passes through. So that's a nice way of doing it. And I'll hit Control G to run it. Oh, actually I'll add, and just before I go in the immediate window there, I'll add a date, start date and an end date so that we know just how long this is going to take us. And I'll set the start equal to now, just before the procedure runs. And then at the very end, I'll say, you know, the end date is equal to now as well. And then we can output that when the procedure is finished. And once we're at the end, I'll do a debug.print, and where we can print our seconds, or our date difference. So what we'll do is date diff, and then S is for seconds, and then we'll put our start date and our end date in, and then we'll put we'll concatenate that with seconds so that it looks nice, and then that'll tell us exactly how things went on that time through. And then I can just say in our immediate window, set last event, and specify the table that we want to run. And in this case, we'll run it on data medium. And in VBA, you can remove the brackets when you call a procedure. And you can see there it's off to the races. It's running through the record set, you know, dumping out, telling us each 1,000 records when it's passed, and that took 8 seconds to complete 100,000 rows, which is actually pretty good. So if you're looking for a lag function, a procedure is sometimes the best way to go. Okay, and so if we go ahead and we take a look at our data big table, that one has 500,000 rows in it, which is a fair bit bigger than the 100,000 row table. And we'll do the same thing. We'll add our last event date time to it, like we did the other one, and we'll save that. And then you can see it's empty here if I open up the view. And then we'll go back to our procedure, and we can sort of delete all of the results from this one here, and then we can rerun it for the big table. So in order to run it on the big table, we'll just change the name of the table we send into it, and there it goes. So it's a little, seems like it's a little bit slower than the table with with the 8-second result with the 100,000 rows, but this one is also, it's going to traverse 500,000 rows, which is quite a bit more. We'll see if we, it looks like we're going to come in at a pretty nice timing on this one as well. And keep in mind, you only have to run this one time, and then your lookups or your analysis can operate off of the table with no query. So it'll be much faster. The next time that you open it, it will be basically instantaneous when you look at the table. So there we go. It looks like it paused for a second there, and then it hit 500,000 records done in 49 seconds, which is a lot better than not completing in 5 minutes. And that's where that one ends there. Okay, so in recap, going back over our results, we can see that our make data table using a DMax as the lag function was successful using a small number of records, like 100 records, and it was okay using 1,000 records, but failed for larger amounts like 100,000. For the medium size of data set, you're going to want to use a procedure, and we were able to populate this in 8 seconds using a simple procedure in VBA, and basically calculating our lag that way. And as you can see, the fields are populated, and the dates are all correct there. And if we look at our big table, you can see the same result. We were able to get in 49 seconds, I believe it was, the dates all populated with the lag data in there, and so you can go ahead and you can do your calculations based off of that, or your drop-down lists or analysis or whatever. And so one of the things that you'd probably want to do is if you opened your table and you have your lag dates created, one of the things that most people will do at that point, they'll do some kind of calculation off of whatever the lag between the records was. And so if we make a query and we include our event date and last event date, we can go ahead and we can create the days. We can calculate the days between the events, so that we know what the difference of days was between the events by using the date diff function, and we'll use D as the argument, and then we'll put our last event and our event date in there, and that's going to tell us exactly how much time is between those two. And so as you can see, if I run that query, query 1 here, then you can see that it's all automatically calculated. I can go to any spot in the table or in the query, and it's very fast, it's very snappy, and that's exactly what you want. And it's all pre-calculated, and so you don't have any problem with not being able to use that data effectively. And that is how you simulate lag and lead window functions in Microsoft Access. I hope you enjoyed today's discussion about lead and lag functions in Microsoft Access, and I hope that you can use this technique in your project, or one of the 2 techniques or 3 techniques that we showed today. If you liked what you saw, please give the video a thumbs up and make sure to subscribe to the channel if you haven't subscribed yet. And if you have any questions or comments, make sure to put those in the comment section below, and I'll make sure to try and answer any questions that you might have about the material that we covered today. So have a great day, have a safe day, and I'll talk to you next time. Cheers.